It is Monday morning. You are the data engineer. Leadership wants a customer churn analysis by Friday. 5 million customer records, 15 million orders, a tangle of dates, strings, and repeated categories. This is the pipeline senior analyst ship every week. Every technique from the last 10 videos in one fluent chain. Load fast, merge safely, shrink memory, extract features, aggregate, cross-tab, and avoid the 2 silent bugs that would have sent the wrong numbers to your seat Evo. Let's build it. First move, load the CSV with types up front. You already know customer ID is an int, region is a category, sign-up date is a date. Tell pandas, it skips the inference pass. Default read CSV on this file takes 32 seconds. With a dtype dict, 6 seconds, 5 times faster. That is 30 seconds you get back every single morning. The lesson: types are certainty, guessing is expensive. Applies to CSV loads, database queries, function signatures. Same rule everywhere. You have customers. You have orders. You need one frame. The naive merge silently multiplies rows if a key repeats. 5 million customers become 14 million rows because one bad customer ID appeared 300 times in orders. Every downstream number is wrong. Your dashboard lies. The fix is one argument validate equals one to many pandas raises merge error at right time. You catch the duplicate before analysis. This one keyword is the difference between shipping insight and shipping fiction. 14 million joined rows in string dtype. Your notebook hits 2.4 gigabytes of AUM. It crashes on the next aggregation. The fix: cast repeated strings to category pandas stores each unique value once, plus a small integer per row. 2.4 gigabytes drops to 220 megabytes, almost 11 times smaller. Notebook stops crashing, and every downstream operation stays cheap. Now the transformation: filter to active customers with .query, then chain.assign with lambda for 6 derived features, sign up year and month from the DT accessor, weekday name, email domain via SDR split, a corporate flag using SDR and SWIFT, tenure days from a date arithmetic expression. Every column can reference the ones defined above it because the lambda sees the frame in flight. This is what modern pandas looks like. One expression top to bottom. 0 temp variables. Code reviews take 5 minutes, not 50. Now the cohort summary. Group by region. Aggregate with named keyword arguments. Customers count. Revenue sum. Average order value. Max tenure. Latest order date. 5 metrics in one call. Flat named columns. No multi-index mess. This runs in a single pass through the data. On 14 million rows. 3 seconds. Before groupby.agg with named aggregations, this was 5 separate groupies and a concat. 20 lines of code that no one wanted to review. Now it reads like the report itself. The final report deliverable: churn rate by region and month. One pivot table call. Index is region. Columns are month. Values are the churn boolean adfunc is mean, which gives you the rate margins equals true adds row, and column totals for free. This is the exact shape leadership wants to see. You did not export to Excel. You did not open a BI tool. 9 lines of pandas produced a dashboard-ready grid. 2 silent bugs your dashboard would have shown senior leadership. First, if you had written high value equals merged bracket filter, then high value tier equals gold, you would get setting with copy warning. Sometimes the update lands, sometimes not. Depends on RAM. You used .lock combine filter and assign. Guaranteed. Second, when you sorted cohort by revenue and called .lock bracket 0, you would get a 2019 customer instead of the current top region. Because lock reads labels, you used .iloc bracket 0. Position, not identity. Both bugs avoided at right time, not caught in review at week 2. The principle bigger than pandas. Modern pandas is a fluent chain of atomic operations. Every step declares its intent. Load with types, merge with contracts, shrink with categories, transform with lambdas, aggregate with names, update with .lock. Each of these has an equivalent in SQL, in Spark, in Polars, in DuckDB. The syntax changes. The rules do not. Once you internalize this, you stop debugging pandas and start designing analyses. That is the difference between a scripter and an engineer. You finished the Python track, 10 patterns, 1 mental model. The next tracks build on this. Power BI, where the analysis lands in front of executives. Azure, where the pipeline runs on a schedule. Agentic AI, where you build the tools that answer the questions before anyone asks them. Subscribe and ring the bell so the next capstone lands in your feed. And tell me in the comments which track you want next. The most requested one starts Monday.